Good morning, everyone. As Aaron presented me, I'm Maria Ignacia Rodriguez. I studied industrial engineering in Chile, and then I graduated SINReM now in September. So today I want to speak a little bit about my thesis, and as you can see, I presented a holistic sustainability assessment of an improved organic waste collection system and its valorization using insects. These are eco-innovative solutions that I created for the city of Ghent and its surrounding neighborhood called dissertation. This was done under the guidance of Professor Jode Wolf, whom I don't know if you've met, but for sure you will. And then Tom Kleijs from the Intermunicipal Association of Waste Management in Ghent and surroundings, called Divago. And obviously this company was key when it came to the data collection stages of my work. And then also my tutors, they helped me from start to finish, Sue Ellen and David. Okay, so you may wonder what's the problem that I wanted to tackle with my work, and also how is this related to SINReM? Like, I'm sure that when you applied, insects was the last thing that you thought about. But anyways, in the last decades, linear rather than a circular economy has been predominant and has been described as take, make, and waste. I'm sure you know all about this. Therefore, obviously, this has resulted in intense resource use, in high emissions, and also in major negative environmental impacts. And therefore, several efforts have been taken at a European level with, for example, the Waste Framework Directive, in order to contribute to a more circular economy and therefore have more circular societies. Now, this is the core of SINReM. SINReM is all about innovation and the development of sustainable ideas. And Ghent University, where I did my major, focuses on resource recovery, on the design of sustainable processes, and also is a place where waste is seen as a potential resource. And this is why I chose to do this thesis, because I wanted to understand what the value of waste was that everyone was talking about. Also, organic waste is, in my case, organic waste is a waste stream that is generated all over the world, in all of your countries. So this is one example of a situation where you can grab some knowledge in SINReM and not only apply it to Belgium or Europe, but also bring it back home and maybe apply it there. Okay, so to set goals and targets regarding waste, it was necessary for me to understand the composition and also the amounts that are involved in the generation. So what's the case in Belgium, and why do we have to innovate to become more circular? This graph shows that from all the non-separately collected waste in Flanders, around 80% comes only from households. Now, all of this fraction goes to incineration, where heat and electricity is recovered. Now, this may sound like a good way to treat waste, and I know in some countries this is not even done yet, but keep in mind that the quality of the energy that you're producing and also the efficiency of your process will be affected by the waste streams that are present in what you're burning. So if you have a lot of organic waste and you burn it, you have a lot of humidity, and then your efficiency will be lower. Also, the European Union has been very strict about burning recyclable waste or compostable waste, which is obviously not in one of their objectives. And even though this number has been showing a decreasing trend in the past years, sorting analysis still show, so that means that people are actually separating their waste in a better way. Still, sorting analyses have shown that there's a considerable percentage of waste contained in the mixed waste of houses that corresponds to either recyclable or compostable waste, and obviously they were wrongly sent to incineration, even though they had the potential to be valorized in another manner. And this brings me to the research question that I presented in my thesis, because in order to find the valuable resources that I'm talking about in waste, it is of utmost importance not only to consider the environmental effects that sustainable ideas or innovative ideas might have, but also what are the social challenges or the economic costs that we will have by implementing them. And this might not be super obvious in some countries where, I don't know, there's a high political or social or economic stability, but I know for sure that in some countries you cannot even begin to talk about the environment without tackling some social challenges before. Okay, sorry. So Yeah, for my work, I had to carry out a sustainability assessment framework for the ideas that I developed. And I want to briefly introduce it to you because I want to give you an example of one of the tools or frameworks that I had access to while following SINReM. So this was done for the assessment of scenarios related to waste management systems. It's a project from Horizon 2020 called Repair. And its goals are to address global and local impacts. So the nice thing about this framework is that it allowed me to understand all the impacts in a spatially differentiated way. So as you can see, some example, I don't know if it's clear, but some examples. So here we have the economic, social, and environmental aspects. Some examples for the economic one are capital, operational, end-of-life expenditures. And here you really have to calculate and understand if the revenues of your ideas are going to be higher than your costs. Then for the social ones, one may wonder, is the total employment of the system by implementing my ideas going to increase or decrease with this? Has the effectiveness in changing the behavior of people increased or decreased with my ideas? How is the life of the people that are involved in each step of the waste management system going to be affected by my ideas? All of this you have to answer. And then also for the environmental ones, more typical life cycle assessment indicators were taken in consideration. For example, land use or global warming and water use. And then for these last two, as you know, they not only affect the environment directly, but also society. So they become socio-environmental issues. So how do we tackle this? How do we link these indicators? How do we know which one is going to be more important than the other one? These are all challenges and questions that you will have to answer in the next 2 years if you want to develop some sustainable solutions. Also, the nice thing about this framework is that it defined a methodology to aggregate all of these impacts that I also had to calculate, so it was a lot, and then integrate them into 5 different areas of protection that are in these black boxes. So I don't know if you can see them, but they are prosperity, human well-being, human health, ecosystem health, and natural resources. So those were my endpoint results, which were a little bit easier to explain than all the other ones. So I will try to make this very simple, but basically this is my strategy. So I took 4 changes compared to the reference scenarios that are mandatory separation of organic waste, natural gas for the trucks that collect waste, increased frequency of collection from a bi-weekly base to a weekly base, and then the valorization of organic waste was done through insects. These 4 ideas, I implemented them in 6 different scenarios. And just to give you a little bit of context, Ghent is separated in zones when it comes to waste management. So the Z zone and the apartments are areas where it is not mandatory to separate the organic waste. So if you live in the center, I'm sure you know you can throw your organic waste into the mixed waste bag. In the C zone and Westerbergen, it is mandatory to separate your organic waste. So the green blocks, they represent the organic waste that is collected. And then the red one is the organic waste that is contained in your mixed waste. So the one that you don't separate. So basically my first scenario was, I said, okay, what will happen if now we make all the areas mandatory? So everyone has to separate their organic waste. Also keep in mind that the natural gas I used for every single scenario because this is already changed. Like the reference scenario was from 2016 with diesel. So the natural gas trucks were everywhere. And then in my second scenario, I said, okay, if now we made it mandatory, you know, in Ghent, I'm sure some of you live in a cot or a small apartment or something. It's very difficult to have for 2 weeks your organic waste there with the odor, and yeah, some people don't have enough space. So I said, let's pick up the waste on a weekly basis to avoid any problems. For this, I created 3 different scenarios with 3 different capture rates that I assumed for each one. And then in scenario 3, I said, okay, let's not change anything. So it is not mandatory. We do not increase the frequency of collection. We do use natural gas for the trucks, but the organic waste will not go to anaerobic digestion and composting. It will go to a black soldier fly treatment plant. And this, just to see the impact of my valorization stage. And then here, the black soldier flies bioconverted the waste into 4 different products. It was BSF meal that had the potential to substitute soybean meal, then fresh puree that I assumed had the potential to substitute chicken meat on a protein basis, then lipids that I substituted rapeseed oil, and then fertilizer that substituted normal chemical fertilizers in the market. And then finally, in scenario 4, I just took in account all of my solutions. So now it is mandatory to separate your organic waste. We will pick it up once a week. We will use natural gas, and we will take it to the insect plant. I can imagine that some of you might think already which scenario was a little bit more sustainable than the other ones, but if there is one thing that you will learn in SINReM is that you never make these assumptions until you really calculate them, because I made a lot of mistakes by assuming these things. And then I will quickly jump to the conclusion, because you can imagine I had like 10,000 results. Basically, scenario 4, where I combined all of my solutions, scored best in 4 out of 5 areas of protection. The only one where it didn't score best, where actually the reference scenario scored best, was in natural resources. And this was because, it was impossible to compete with the amount of heat and electricity that was being produced in the incineration plant. And in the reference scenario was the one where the biggest amount of trash was going there. So here you really have to decide go for a trade-off and say, okay, do we want more incineration, or do we want to give the waste a higher value, but by valorizing it in a different way? And then also because in my insects plant, a lot of natural gas and electricity was being used. So maybe you will find a solution for that, and you can assess it with renewable energies or some industrial symbiosis or something like that. And then, finally, the research gaps for the bioconversion technology were a huge limitation for me. And I'm sure a lot of you will be in a situation like that, where you will not find information, people won't reply your emails, it's going to be difficult. But as Professor Delane said, you guys all have different backgrounds, so talk to each other. If you have to call an author, you just grab the phone and call them, right, everyone, but try to get the most accurate information. And then also, my insects products were limited by public acceptance because, in Belgium, no one eats insects, and legislation as well. And then further studies could include the use, for example, of other insects or other collection schemes, and also assessing other eco-innovative ideas, which I guess will be your job now. And thanks for your attention. I cannot stay for the rest of the event, so if you have any questions, you have my email, you can just contact me. I'm starting my PhD here, so you will see me around and you can ask me anything.